Hey, glad you're here. I got something to show you. This is a fig tree. We don't know much about figs since we just bought this property a little while ago, but you're going to know a lot about it. And this is being researched in Asia, and the fruit's being researched in the Middle East for memory loss. And that's the theme of today, is memory loss. Let's talk. Don't you hate it when everything's upstaged by nature? This is our resident local turtle that's become a friend. We feed periodically. And that's Roxy, basking, waiting for some sardines or something. These fish that have grown up around our dock here are amazing. And there's yet another turtle trying to catch in. The word is out that I feed Roxy and they want a piece of it, but look at these fish. They're kind of scaring each other. There's been a real bloom of fish here locally. I have no idea what kind of fish they are, but I'm sure they're kind of a feeder fish. So what I want to tell you about memory loss is what we've been a theme about mild cognitive impairment, mental clarity, brain fog, et cetera, et cetera. There's been a lot of research in the last 4 years on both sides of the Atlantic, which I've mentioned before, but when I want to break it down for you, it really comes down to two things: B vitamins, and in terms of research, and omega-3 fish oils together are sensational. We're going to go into the labs in just a second, but the reason this is important is because homocysteine, you'll learn about in a second, is considered such a brain toxin. So let's go look at the labs and see if that's true, and then we'll look at the research. Okay, now I want to give you a little bit of a support, a little foundation of what I've been talking about. Some research, and then we're going to go to labs, because labs is my way, being the physician and having all these labs, seeing patterns over a number of patients. Can we speak truthfully about a certain study? Does it ring true? Is it applicable? Is it some sort of information that we can actually go use individually? So it keeps it from being esoteric and something there in your face that you can use starting today, tomorrow, whenever. Okay? So anyway, here's where I go for that. So this is what they call the VitaCog study, a vitamin cognition. It started about 12 years ago in the UK, and it's gone on. But it started with this, B12 folic acid, which has then subsequently been changed to folate, but that was back in the day. They didn't know the difference between folic acid and folate, and vitamin B6. So why these three? I'm going to show you why these three. In fact, they don't even go into why these three. They just say, well, we gave these three and Shazam. Not exactly Shazam. What they were measuring was homocysteine in the blood. And I'm sort of spoiler alert here. It's saying, well, those who had elevated homocysteine and took these supplements did really well, had cognitive improvement, and with omega-3s, no more brain atrophy and even mental clarity. So that was something. But looking behind that, why did those people have elevated homocysteine? Why do some have elevated homocysteine and others don't is a subset question. And that's more about genetic predisposition than it is about diet. For sure it's about diet. I mean, for those who live rurally and have good sources of meat and eggs, and you could say, you know, vegetables as well to an extent, they're good. But few people eat that way. But not everybody eats potato chips 24/7. So it's really about a genetic predisposition in the era of what they call hypernutrition, in the era of eating a lot of calories that have no nutrition in them. So they're starving. They're just like the World War II Dutch hunger study where they're all starved. What happened when they all starved? Well, they all did very poorly, and a number died. I think, I don't know if there's a million, but many hundreds of thousands died at that particular time. But they also had elevated mental diseases and other things associated with those with specific mutations. Specific common mutations. That's when we get into it. Anyways, here's the VitaCog study. What I wanted to show you, this is the brain regions that are protected, the atrophy is protected by B vitamins. Nobody really thinks about B vitamins in brain. It's not your whole brain, right? We tend to think everything is black and white. B vitamins are good for my brain. They're good for parts of your brain. They have to do with the parts of learning and memory. They're pretty important parts. And attaching your prefrontal cortex to the rest of your brain, so your thinking part of your brain, if you will. Well, brain is thinking, but your reflection and your extra little, what am I going to do and what does this mean? Your interpretive powers, your executive powers, as they say. Most likely to improve were those who started out with high blood levels of homocysteine. Homocysteine levels fell in the treatment group, given the folate, B12, and B6. I'm going to show you why. But they did not fall for those who took the placebo. So now they know it's a real thing. You're either, if you have high homocysteine, then you had high homocysteine in the placebo group, nothing changed. In the other group, it changed and things improved. So the summary of the study was of adults with MCI, mild cognitive impairment, showed significant benefits from high dose supplementation with B6, B12, folate in terms of reduced physical brain shrinkage, slow cognitive decline. It slowed it. And they did a lot of tests for all that. And these beneficial effects of B vitamins depended on the omega fatty acid status. So just getting, it's like a subgroup. So just getting the B vitamins and having elevated homocysteine was helpful, but it wasn't that helpful if you didn't have enough omega-3. So what it said is no reductions in physical brain atrophy or in cognitive decline. In other words, it kept on happening for participants with low omega-3 levels at baseline, meaning those who were deficient prior to the start of the experimentation in omega-3 had no benefit when they received the B vitamins without having enough omega-3. That's why we call fish brain food. Brain food is, fish are fairly high, and depends on your fish, of course. Fish are actually not very fatty. So the fatty fish are your salmon and actually your Arctic fish. Arctic chard, and fish we generally don't have access to for the most part. Okay, so the question remains, what people would most likely benefit from this treatment of the B vitamins? Those with A, deficient in omega-3s, that is they're deficient, they took their omega-3s, and they had their B vitamins, right? But on the omega-3 side of things, when we look at this, and we're going to look at labs, so those who are deficient in omega-3, but also those who have a really high omega-3-6 ratio, right? Think of Artemis Sinopoulos and the whole idea of it's a driver of chronic illness is that ratio of omega-3-6, hugely bad. Regarding improvement with folate supplements specifically, a whole different study, 23 studies of folate, this comes out of Malaysia actually, 23 studies of folate supplements in psychiatric disorders. Of these, this is looking at all the research that's out there. Of these, 9 studies looked at the efficacy of folate supplements with major depressive disorders, schizophrenia, 6 studies from autistic spectrum disorder, 2 studies of bipolar disorder, 1 study of attention deficit hyperactivity disorder. The most consistent findings association was improvement in major depressive disorders, including postpartum depression for many moms, postmenopausal depression, schizophrenia, autistic spectrum disorder, and attention deficit hyperactivity disorder, and bipolar. So that was 2015, and that has to do with MTHFR, C677T polymorphism. We're going to get into it, so don't be afraid of that word, and the associated diseases. So here we're looking at what they call a folate cycle, the methylation cycle, and this is really what they call transsulfuration, or I call it the glutathione factory. So why are folate, B12, B6, choline, and omega-3 so important? Here we go. Folate, obviously really important for the folate cycle. That needs to be combined, methylated with B12. So there's B12. Choline, choline has a lot to do with beta E and all these other things, but basically it helps with the methylation cycle. And here's the test that we're going to look at in labs, homocysteine. So when that is elevated, taking these other supplements, and what does B6 have to do with anything? B6 is very instrumental in getting your glutathione produced. So homocysteine can either go down and be made into glutathione and other things, of course, or it can go back into be recycled in what they call methionine. Methionine you get from animal products, not from plant products. So it's a recycling, constant recycling. And you've heard of SAM, acetyl methionine, and so on and so forth. I'm not going to get into that here, but for decades we would give SAM. It would help people with major depressive disorders, and we didn't really know why until really about 15 years ago, until we got into the metabolomics, if you will, the nutrigenomics, about finding the interaction of genes with nutrition. Okay, this is why these are critical. Folate, B12, B6, choline. Okay, so this is how we start to look at people's mutations, right? briefly, how to assess genomic predisposition. These are some of the key things. There's a lot you can look at, and you can get lost. It's a huge rabbit hole of look at all these possibilities, and they're not of equal relevance. Some are very important, and you really need to find out what mutation do you have. And it's pretty easy to do it nowadays, luckily. And I'm sure there's going to be more in the future, but these are the ones that we can connect studies to genomics, the metabolomics is what they call this. And we go, that makes sense. So this is where MTHFR, this is the one they're talking about, C677T. It's just like me. I'm homozygous for that. I have a higher need of B12 and folate. So where do I get that? I get it from, I do liver a little less than I did before, but I get it from animal products, certainly, and I get it from egg yolks. That's where I certainly get my choline. So MTRR, another, we're going to look at this in a second, another B12 folate. Glutathione is B6 driven. Choline, this is a big mutation for many women. Many women postpartum, many women postmenopausal. It's because there's an estrogen association. When their estrogen drops, they have a big problem. Okay, so a quick look at some panels of what they call SNPs, single nuclear polymorphisms. These are the same things we've been talking about. This is a whole glutathione collection of relevant mutations. These are really the only ones that I look at for this particular individual. He's heterozygous for some, 3 heterozygous and 1 not that relevant. Here's a homozygous, so the blue bars are heterozygous, heterozygous, and the red are homozygous. And so you can see that I look right away at the ones that are homozygous. These are not of all equal importance. So one can say, oh wow, he's homozygous, that could be a problem. It's not that powerful of a mutation alteration to really worry about it. The ones to worry about are the ones that I have the green circle around. Here we have about folate. I told you about folate. These are the same mutations we looked at. Heterozygous, heterozygous, homozygous for this particular one. We just saw that study from Malaysia saying it's associated with all these different things. And that's just that one mutation. There's others, if you look collectively at what sort of impedes the methylation and the folate, what sort of slows it down, like that engine we were talking about. We can ungum it. We can make it work more smoothly by simply assessing it for one, right? That's taking your car and getting it assessed and then giving it what it needs. So it needs more folate. It needs more of B12. Then you can even do special forms like methylfolate and methyl B12 to make it a little easier, but certainly more. Here's again, all related, S-adenylmethionine, but it's really related to methylation of B12 as well. All is heterozygous, homozygous. There's choline. That's a big gene to be worried about. Okay, here's another way we're looking at. We're looking at these bottlenecks. These are the genes that if you have these mutations, they slow down, they gum up the engine, so to say, but they can be ungummed by giving it appropriate. So just like in the studies, it said, not everybody got a benefit. The only people that got a benefit had elevated homocysteine and those who had adequate enough omega-3s. Makes sense. Boom, boom, boom. And you can put in choline over here. It's just not on this particular schematic. Here's choline to betaine. It helps bring homocysteine back to methionine. So it helps reduce homocysteine, and that's the whole thing. Homocysteine is a neurotoxin. You want to get that down, not down to 0, small numbers, under 5 ideally. And if it's over 14, you have twice the risk of dementia and Alzheimer's. Above 14, we're going to look at that. Other studies relative to this, we're not going to go into it, but I'm just going to give you some titles. Preventing brain loss with B vitamins, 2015. Homocysteine and folic acid, 2021. Risk factors for Alzheimer's disease in an updated analysis. Conclusion, homocysteine and folic acid are potential predictors for the occurrence of and development of Alzheimer's. That's amazing. Homocysteine, neurotoxin, and folic acid, meaning a deficiency. MTHFR, C677T, and dementia. So it's usually a bigger thing, and this is just, they're looking at one particular mutation, another one on C677T, and Alzheimer's risk. Results associated with Alzheimer's. All right, now let's go look at the labs. Okay, so these are some labs. I'm going to blind you with some numbers, but I'm going to do some summary. So these are just a lot of labs I take on roughly the last 20 patients, clients that I worked with. Okay, but what I'm going to show you is now we're scooting through all these things, and I'm just simply showing you that there's more labs I take than we're going to be talking about, but here's some summary. I put homocysteine repetitively, homocysteine compared to lipid panel, homocysteine compared to insulin resistance, homocysteine, omega-6. And I want you to see that there's some relevance, not for all of it, but there's some relevance. So look at homocysteine relative to the lipid panel. So the lipid panel is the triglycerides, HDL, total cholesterol, and your LDL. And so we're looking at, there's homocysteine, right? And I ranked everything from the highest homocysteine to the lowest homocysteine of roughly 20 people. And they didn't all get 100% of all their labs because they got them in different places and so on and so forth. But the highest is to the left and the lowest is to the right. So we're trying to see for a correlation. Do we find any correlation with the lipid panel? In other words, do we find high cholesterol versus low cholesterol? No, actually, it's probably just the opposite. The lower their homocysteine, the higher their total cholesterol. The lower their homocysteine, I guess you could say their HDL is about the same. Let's go to another one. Here's for the insulin resistance. So the higher their homocysteine, right? The higher their homocysteine, and these are the labs for insulin resistance. So we say these are different ways for me to compute that. And I did a video on looking at the different ways to assess how insulin resistant you are. One is triglyceride over HDL. That's a pretty sort of the poor man's working insulin resistant formula. And HOMA-IR, so we're saying, is there a correlation of elevated, the high versus the low? You can say it's not strictly correlated, but look at some of the people that, like this guy, happens to be a guy, who has the highest homocysteine, also has the highest insulin, has, I don't know about the worst glucose, but he has pretty high insulin, certainly high insulin resistance. Now when we go to the omega panel and the omega-3. So this is the omega-6-3 panel, and this is the omega-3 by itself. So they call that the omega-3 index. We're just looking for correlation. So we do find the highest, when you just look at red, is there more red to the left than there is to the right? And you're going to go, well, sort of, the numbers are a little higher, but it's a loose correlation. But you can add up relative to the story. Remember, those who had low omega-3 didn't get the benefits of taking the B vitamins. So they had to have sufficient omega-3. So we're talking about this number right here. So these people, not many people, who's the highest? Here's the highest, 7. You want to get over 8, by the way. So none of them got over 8. So you could say the higher people, of the 7.2, there's another 7.2, they would get the better benefits of the B vitamins if their homocysteine was elevated. Their homocysteine wasn't that bad. You want it under 7. You want the homocysteine under a 5, actually, under 5. And so they would be in a better position to reduce cognitive impairment. They would be in a better position to reduce brain atrophy. Also, homocysteine compared to inflammation. So we compared to CRP. I use SED rate, which is an old-fashioned. And I even threw in glutathione, and I've only started recently to do it. That's why not everybody has it there. Glutathione is not an anti-inflammatory, it's an antioxidant that the body makes. So they're similar, but they're not the same. Okay, and then we end up with homocysteine relative to red blood cell folate, serum B12, and methylmalonic acid. You look at all these together, and they're all kind of vague answers. It's not black or white. So in other words, you would think that the person who had the highest homocysteine would have the lowest B12 and the lowest folate. It looks, and there we did a vitamin D as well. It's loosely correlated. So that's why I use a whole nother panel to do intracellular nutrient deficiencies, because in serum, it's hard to detect water-soluble vitamins, such as B vitamin deficiencies via these tests. They're okay. You do the methylmalonic with the B12 to kind of a belt and suspenders approach, and they're okay. But anyway, so we're looking at the highest homocysteine, and we have the lowest methylmalonic acid, which correlates with B12 deficiency to an extent, but it's still pretty vague. So we can't go there exactly. So we would say the fish oil, the omega-3s are probably the strongest. We have the insulin resistance is probably up there as well. So that's about as far as we can go. But locking this in, we're taking these studies and going, so what does our results say? Our results say, wow, the person who has the highest homocysteine also has the, let's go to the inflammation, has the highest, one of the highest inflammations, more elevated inflammation to the left than to the right for sure, a more lower total cholesterol to the left, and then to the right. So what was the bit about the fig thing, right? Well, it ends up that when I was looking into some studies, there was 2 studies. One was out of Malaysia about the use of fig leaves, and I put it right down here. And figs are called ficus, by the way, and it is a native American herb. It's also a Chinese herbal medicine, so it's used in various formulations. So this is out of Malaysia, and it talked about using fig leaf, specifically fig leaves, for memory loss reduction in mice that were given a drug, scopolamine, to reduce their memory. So it reversed the effects of scopolamine. That's pretty interesting. And then there was another study that I didn't post here that specifically had to do with the fruit of the figs from Oman, so the Middle East, which is basically we think the origination of the fig and the whole biblical aspect of the land of milk and honey and figs in particular. And you think of how biblical fig leaves are. But basically what you need to know is that figs are not really fruits. Figs are a flower that is folded in on itself, and technically it needs to be fertilized or cross-pollinated with by a specific wasp, but I think they've gotten around that now and they're self-fertilizing. But these are all the ovaries, if you will, of a lot of different flowers. So because the way it's made, it's not just one ovary, which is what your fruit is, whether it's a peach or a plum or something else. It's a whole different kind of fruit, but it's not technically the stereotypic fruit you think of. All right, so now you've seen that there's a correlation with homocysteine as a neurotoxin, a cerebral neurotoxin, with a number of things. Not specifically lipids, not specifically inflammation, not specifically insulin resistance, as we showed you, but collectively, some of those cases, you went right down the line and you thought, oh my gosh, you know, they really have a lot of things to work on that can be addressed, by the way. It happens to be, if it's up to them. But homocysteine as a single factor is a very big deal. You also saw that it's very much related to one's mutations, SNPs. Single nuclear polymorphisms, specifically MTHFR, MTRR, and some of the other ones we went over. But collectively, you look at that and you go, you know, that's like an engine. It's kind of gummed up. It's got a few problems here. That doesn't make it that you can't work with it. It means you have to address those things, just like you do with an engine. Add the lubricant, replace this part or that part. It can be done. And it's important to address those things. As that study showed you, that the improvement was only for those who were deficient before the study. Once they got the B vitamins and the omega-3s, they did spectacularly well. But not that those didn't have a problem. So if they weren't deficient and didn't have the mutations, it was kind of irrelevant. That's the takeaway. It is not for everybody, but it is for a strong majority. And when you start looking at the correlation of dementia, Alzheimer's, a lot of neurological issues, this fits and can be addressed. And when you add in the choline, which is actually a newer level relative to those studies we looked at, adding that into those particular mutations as well, you have a home run in terms of learning how to address this and making a big difference, whether it's in cognitive decline, mental decline, Alzheimer's, dementia, brain fog. These are the things that you can address. The earlier, the better. So if this is a kind of video that you like, that we go deeper into a smaller area that has a lot of relevance to a particular population, let me know. Because my way is going, what are the labs about? What's the research about? Let's be real. It's just not hypothetical. It's not like, oh, I've read 10 different abstracts and therefore this is the conclusion. I take that idea and let's look at the labs. Do the labs tell the story that we have just learned about in these particular studies? If they do, that's a home run. If not, then it's too esoteric. But let me know if this is something you're interested in. Thanks.